Welcome back, students. In this video, we're going to look at Grignard reagents and protecting groups. Remember in our prior video, we said that Grignard reagents cannot form in the presence of an acidic proton, especially if that acidic proton is part of the molecule. So if the acidic proton is part of the molecule, what the heck are you supposed to do? I want to form a Grignard with this. And what I want to have happen is for me to get the magnesium inserted between the bromine and the carbon so I can get this as a Grignard reagent. But it's just not going to happen because this OH is incompatible with the formation of the Grignard. So what do? Well, step one is going to be protect the alcohol. When I say protect, I actually kind of think of it as like an invisibility cloak. I know that's super lame, but I really liked Harry Potter. So imagine Harry Potter put on his invisibility cloak. He covers up this OH and the Grignard can't find it. The Grignard can't react with it because it's covered up. So then you carry out the Grignard reaction and then you can take off that invisibility cloak. So that's going to be what we do. We protect the alcohol. We carry out the Grignard reaction, and then we take off the protecting group. Let's look at how we do each of those. When we protect that OH, that alcohol, what we do is allow it to react with something called trimethylsilyl chloride, which is TMS. TMS looks like this. And what happens during the course of this reaction is the ET3N, which is triethylamine, it's a base, pulls off the proton on your oxygen, and then your oxygen can sneak in and attack the silicon and displace the chlorine. And you're thinking, wait a second, why are you allowed to do that for that tertiary silicon, but you couldn't do that before for other substitution reactions? Yeah, because silicon's not the same as carbon. So you're allowed to do it for silicon, but you cannot have that be successful for carbon structures. So the oxygen stays there, and then you get that TMS group attached. If I wanted to redraw this to show what it actually looks like, remember Me is methyl, it would look like this. But that's a lot to write, so we just write OTMS. This is the protection of the OH. Now that that OH is protected by hiding the hydrogen, we hid it by removing it, now we can carry out the Grignard reaction. The first thing that we're going to do in our Grignard reaction is we are going to make the Grignard reagent. So step one here would be to make the Grignard reagent by adding magnesium and anhydrous ether. Ether is just the solvent, and remember that it's anhydrous because it's without water. Then once you have created the Grignard reagent, you can add your ketone or aldehyde, and your Grignard can attack the carbon of the carbonyl. And I'm not going to draw out the full mechanism. I'm just going to draw out that part to help me visualize how these things are going to be attached. So I'm going to have my OTMS here, and now this carbon is this carbon, and it's going to be attached to this carbon, which is this carbon, which has 2 groups attached to it. It's really easy to lose carbons or gain carbons in your Grignard reactions, so I always suggest going back and double counting. For example, I would go back and count 1, 2, 3, and over here 1, 2, 3, 1, 2, 3, and 1, 2, 3 to make sure I didn't lose any carbons. I did lose my oxygen, so I need that O- here. And now we can talk about not only how to protonate that oxygen, but remove the OTMS. When we want to remove the protecting group, there's 2 ways to do it. One way is to add some H3O+. Another way is to add fluoride ion. One way to add fluoride ion is with a compound that's abbreviated TBAF, which I like to call TBOF because I think it's faster. It's a nitrogen-based compound that has these really long alkyl groups on it, and the nitrogen has 4 alkyl groups, and that makes it positive, so there's a fluoride counter ion. Personally, even though they're going to do the same thing and they're both going to take this TMS part and replace it with hydrogen, I really like to use H3O+. Why? Because remember, this oxygen is negative after our Grignard reaction, and adding H3O+ does the double whammy. It goes ahead, it takes off the TMS, and it protonates that O-. So there's less work. Of course I want to do that. If I just use TBOF, TBOF isn't going to protonate that O-. So I would need to make sure that I still have something added to the flask that can be a proton source for that O-. The overall process is pretty lengthy, right? The first thing that you do is you start off with TMSCl and a little bit of base, and that's going to get you to the OTMS, which is where you protect that alcohol. Then you can create the Grignard by adding magnesium and anhydrous ether. Then you add whatever carbonyl compound you want to add. And then finally, I like to just add H3O+ at the end because that goes ahead and it protonates my O- and it takes off the TMS to recreate the alcohol. Let's wrap up. In this reaction, we looked at Grignard a little bit more thoroughly and how alcohols need to be protected for Grignard reactions. We looked at how you can add the protecting group, then carry out the Grignard reaction, and then finally remove the protecting group. Thanks so much for your attention. This is Katoni signing out.